want to go ahead and take a look at some trig sub. This is a material that's not on the AP test, but it is incorporated in many college courses. So I go over it with my class. If you don't go over it with your class, there's really no use for this, but if this is something that you do cover, hopefully this helps. So trig subs, it's a technique of integration, and it works out. I'm only going to show two of the ways. There's another way with using a secant theta, but I'm going to show you two of the ways. So if you see something in the problem with the square root of a squared minus u squared, or square root of a squared plus u squared, where a is a constant, u would be a variable. Trig sub can a lot of time work out real well. Now if you see this in the problem, but there's something else that's easier to use, like u sub or something like that, use that, because trig sub, as you'll see, is a little bit lengthier. So anyways, I noticed that this problem seems to have the square root of a squared minus u squared in there. So first thing to do is I decided, okay, well, in this case then, based off of this, my a would be equal to 3, since 3 squared is 9, and my u would be equal to x. So then what I do is I take my 3, plug it in where I see a, my x, I plug it in where I see u, and I'm going to use the substitution, x is equal to 3 sine theta. Okay, so now I'm going to go ahead and I'm going to make my substitution. I'm sorry, not quite yet. I still need to figure out what's going to happen to this dx, because my variables will turn to theta. So to figure that out, I just take the derivative of this. It becomes dx equals 3 cosine theta d theta. Alright, so now I'm ready to make my substitution. So let's see here what happens. Instead of writing dx, I'm going to write 3 cosine theta d theta, x squared. Where I see that, I'm going to use this x equals 3 sine theta. So I'm going to put 3 sine theta in for x, and I'm going to square it, so it will end up being 9 sine squared theta times the square root of, I have 9 minus, and another x squared, so that x squared again is just going to be 9 sine squared theta. Okay, so now I'm going to go ahead and I'm going to do this kind of over to the side here. I'm going to work on simplifying this, because that's kind of our next step in the problem. Once you make your substitution, is simplifying your square root term here. So it's going to be square root of 9 minus 9 sine squared. I want to see what happens. So here's how I'm going to simplify it. I'm going to start by factoring a 9 out of both terms and get 9 times 1 minus sine squared theta. Square root of 9 is just 3, so I'll bring that outside of the square root, and then I'm left with 1 minus sine squared theta. And from our trig identity, sine squared plus cosine squared theta equals 1. If you subtract sine squared from both sides, you get cosine squared theta is equal to 1 minus sine squared theta. So I will substitute that in here. So again, 1 minus sine squared theta is just equal to cosine squared theta, that's why I substituted it. And I'll take the square root of that, and it just becomes, take the square root of that, and it becomes cosine theta. So this whole square root thing right here just simplifies to 3 cosine theta. And you'll see that that happens in every problem. So once you make your initial substitution, you'll have something similar to this in your square root thing, and it'll always simplify to a cosine theta. See, in this case, a was 3, that's why I simplified to 3 cosine theta. So if you remember that, you could just skip all of that and just plug in for the square root thing 3 cosine theta. Alright, so anyways, I'm going to continue up here. So on the top I have 3 cosine theta d theta. On the bottom I still have my 9 sine squared theta. Where I see the square root right there, again I simplified that, I found out that is equal to 3 cosine theta. Okay, so now that I've done that, I notice I have 3 cosine thetas on top and bottom. Those cancel each other out. I'll go ahead and bring the 9 outside the integrals of 1/9. And then I'm left with 1 over sine squared theta d theta. When you get to this step on a problem, there's just certain manipulations that will need to occur so you can integrate this. And there could be, various different things that might happen. In this case, I noticed that 1 over sine squared is the same thing as cosecant squared, because cosecant theta is equal to 1 over sine theta. So this is the same thing as cosecant squared theta d theta, and it so happens that cosecant squared is an antiderivative that we're supposed to know. it's actually negative cotangent. So then I take the antiderivative and I get negative 1/9 cotangent theta plus c. And I'm close here. I found the antiderivative, but I started with variables of x. I need to finish with variables that are x as well. So let me go ahead and take a look here at this. How can I figure this out? And what you will always end up using, you will use that initial substitution step that you did, and you will use that to make a triangle, because in order to help us figure out what cotangent theta is in terms of x. So I'm going to go ahead and I'm going to, because this relates x and theta together, I'm going to go ahead and divide by 3 on both sides, because you'll see how that will be helpful when we make our triangle. So I have x over 3 equals sine of theta. Make a right triangle. Now, theta is in the spot, when you put things into a sine or cosine function, it's an angle. So theta is an angle on this triangle. Sine, we need to know, is the opposite over hypotenuse. So it's sine of theta, so x is the side opposite theta. 3 is the hypotenuse right here. And this missing side, let's go ahead and use our Pythagorean theorem for that. So let's call that question mark. So to find that, it's, a squared plus b squared equals c squared. So we have x squared plus question mark squared equals 3 squared. So I'm just 3 squared. So I'm trying to go and solve for question mark, so I will subtract x squared from both sides, get 9 minus x squared, take the square root of both sides, square root of 9 minus x squared. Now typically when you take the square root of both sides it's plus or minus, but since I'm dealing with a side length of a triangle, I know it's going to be positive. So we have 9 minus x squared right there. Now you'll notice that's the exact same square root thing that we started with in the original problem, and that will always be the case. Whatever your missing side length is, it will be the initial square root thing in your problem. So I can use this triangle right here to figure out what the cotangent of theta is. So cotangent, okay, I got to think in my mind. I know what tangent is. Tangent's opposite over adjacent. And cotangent is just 1 over tangent, so that means that cotangent would be adjacent over opposite. So this will end up being negative 1/9 times. So on this triangle right here, I look what again I just said cotangent is adjacent over opposite. So here's theta, so the adjacent side to theta is the square root of 9 minus x squared. The opposite side is x, so it just becomes square root of 9 minus x squared over x plus c. And we're done with that problem. Like I said, it's a lengthy process, so if you don't have to use trig sub, it's best not to. Okay, got one more we're going to look at. Okay, here's another problem for us. Now this one we can see, we look at it, it's not a subtraction sign in there, so it's not going to be using this guy, but we'll be using this one, okay? And again, the a is the constant, the b, or the u is the variable. In the last case, it had to be, like we had 9 minus x squared in the last case, it had to be that order. It couldn't have been x squared minus 9. Now with this, we could switch the order, because it doesn't matter if, when we're adding something, what order it comes in. So like you can see, this is in different orders. So even though this is in the front, this is still the u term. So u would be equal to 2x, and the a term, which comes from this, would just be equal to 1. Alright, so then we plug it in, plug u in, 2x in for u, 1 in for a, and we end up getting that 2x is equal to tan theta. And I need to figure out what my dx is, so before I take the derivative, I'll just divide by 2 to get x equals 1/2 times tangent theta. Now I'm ready to take my derivative. The dx equals 1/2 secant squared theta d theta. So now I'm ready to make my substitution into here. So instead of writing dx, I'm going to write 1/2 secant squared theta d theta. Instead of writing the square root of 4x thing here, I'm going to still write the square root, and I'm going to write 4 times, now instead of writing x squared, okay, here's my x. X equals 1/2 tangent theta. So for x squared, if I were to square this, it would be 1/4, because 1/2 times 1/2 is a fourth, tangent squared theta. So again, I'm just taking this 1/2 tan theta, plugging it in for x, but I know I'm going to square it, so it becomes 1/4 tangent theta plus 1. So like I did last time, I'm going to go ahead and simplify this, and I'll do that over here. So it'll be square root of, so if I just distribute this 4 times the 1/4, they will cancel. And I'm sorry, I left this squared out right here. So that should be a tangent squared in there. My fault. Missed that. Make sure you catch that one. So when I distribute the 4 times 1/4, it's just 4. So this just becomes tangent squared theta plus 1. Now there's something we can do similar to the last case using this trig identity. If you divide both sides by cosine of theta, cosine squared theta, I'm sorry. So we're dividing everything here by cosine squared theta. This would become tangent squared theta. This just becomes 1. 1 over cosine is secant, so this becomes secant squared theta. So, you know, that is true that that's happening. So tangent squared theta plus 1 is just the same thing as secant squared theta. Square root of secant squared is just secant. So, where I see the square root thing, I'm going to, instead of writing that whole thing, I'll just write secant of theta. And again, just like with the previous one, that's a rule that we'll always follow. The square root thing, if you make your substitution correctly, in this case using the, u equals a tangent theta, will always simplify to a secant theta. Alright, so I'm going to go ahead and do my substitution in here. Why don't I go ahead and that 1/2 right there, I'm going to bring it outside the integral. It's a constant, so I'm allowed to bring it outside. Secant squared theta d theta over my square root thing, I said simplified to secant. And now I notice I have secant squared over secant, that's going to cancel. Okay, so it's going to end up being secant theta d theta. Antiderivative of secant is one of those weird ones that you're supposed to have learned at some point, but you probably forgot. It's natural log absolute value of secant theta plus tangent theta. So if you look in your book somewhere, wherever that might be, you should see that that is the antiderivative there for that one. Alright, erase this, that's out of our way. And just like in the last case, we can't leave it in terms of theta, we have to change it back to x's. So we're going to use our initial substitution step that we had here to make a triangle. Now I'm going to write that as 2x over 1, just to make it a little bit more clear as to what our angle is supposed to be. So I have my triangle going here. So there's my theta, okay? And so tangent is equal to opposite over adjacent. So tangent theta, so 2x is opposite theta. 1 is equal to, is the adjacent side, so 1 is right there. And I can use Pythagorean theorem to find that missing side, but like I said before, it's always just going to be the square root thing we started with. So you can check me on that if you don't believe me. Use the Pythagorean theorem, but it's going to end up being this. So it's the square root of 4x squared plus 1. Okay? Alright, so I'm going to use this triangle to find what secant theta is and tan theta. So secant, I got to know. Secant is 1 over cosine. So, okay, cosine is adjacent over hypotenuse. So that means that secant will be hypotenuse over adjacent. So hypotenuse over adjacent. So therefore secant theta will just be the square root of 4x squared plus 1. It'll be over 1, but I don't need to write that. Plus, for the tangent, you could just actually go to here and say tangent of theta is equal to 2x. You could use the triangle also, because opposite over adjacent, so tangent theta would be 2x over 1, which is just 2x. And there you have it. There's a couple trig sub problems.